Okay, so in this example, we're going to discuss the difference between average velocity and instantaneous velocity using the example of a road trip to Tampa from Fort Myers. So the only road trip I took this summer was with my wife to go to IKEA to pick up stuff for our bathroom remodel. So I'm just going to kind of walk you through how this trip started off. I think you guys have maybe made this trip before. So you know that Tampa is roughly 120 miles away. And for the first like 10 to 20 minutes or so, it's pretty slow going because you might hit some lights or whatever. And then after about 20 minutes, you get on the highway and then you kind of, you know, your position increases at roughly, I don't know, 70, 80 miles per hour. And then you get closer to Tampa, you hit Sarasota, there's probably a traffic jam and you slow down a little bit, kind of like stay at the same position for a little while. And then when you get to Tampa, you sit in a bigger traffic jam. Maybe you miss your exit to go to IKEA. And so it looks like you're not really going any further for quite a while. And at the very end, you make it. So I'll say right there, after about 2 hours, you get to IKEA.
Sounds about right.
Okay. So that's kind of the way that this looks. I don't know. I wanted to draw this slightly different. I'm going to delete this. Right at the 100 mile mark, you get stuck in traffic in Tampa. And then you make it a little bit further and you make it to IKEA. Okay.
Yeah, so if you're stuck and you're staying still, your position is not changing. It's not decreasing. That would be if you went the wrong direction, right? Or going backwards somehow, but it's staying the same and then increasing again.
Okay, so Katie, what is the average velocity for this trip if we went 120 miles in 120 minutes?
Well, I would do 120 miles divided by 120 minutes, and I get about 1 mile per minute, which we normally think of as 60 miles per hour.
Yeah, it's 1
but
mile
I guess you
per
can say
minute,
1 mile per minute.
Or you could say 60 miles per hour is how we usually talk about it in colloquial terms. Perfect. So, okay, so yeah, that was the answer I was looking for. And now I guess my follow-up question is, were we going 60 miles per hour the whole time? I mean, I think everyone in this class knows the answer would be no. Chances are at some point you're going faster than that, and definitely at some point you're going to be going slower than that because you're going to be stopped at a red light or in a traffic jam or something. So let's just kind of estimate what the instantaneous velocity was at t equals 60. That's when we were just traveling along here through on Interstate 75. And I don't know, it's hard to estimate what the slope of this curve is because I didn't draw the graph all that well. But it's probably about, 70 to 80 miles per hour, which would be the slope right at this point right here, right? So this instantaneous velocity is asking what is the slope of the tangent line right there. And so we'd have to calculate this slope, maybe estimate it by going from 40 to 80 here or something, right? But I'm gonna say we're going faster than 60 miles per hour when we're on the interstate. And then the more obvious question is, what was the instantaneous velocity at t equals 100? Well, that's where I was sitting in a traffic jam in Tampa and not going anywhere. So at that point, I would say it's roughly 0 miles per hour. Of course, it was probably closer to 5, but still. Does that make sense? Like, we're definitely.
Yeah, and I mean, we're just eyeballing this as an example to show how instantaneous velocity in real life can be really different from average velocity. Of course, if you're asked a question like this on a quiz or homework, you'd either be giving a function where you can actually sort of plug in values, right, to get a better estimate than just 70 miles per hour. Or it would be a little bit easier to see. This is just for an example.
Yeah. And I guess the last thing I wanted to say was average velocity is going to be over a time interval. So you're going to have like a starting and ending point, whereas instantaneous velocity is you're supposed to calculate it at a specific point in time. T equals 60 or t equals 100 or so on. Does that make sense?
Yeah. Before we end, could you draw the line from the start to the finish? That secant line from t equals 0 up to t equals 120?
Sure, I'll do that in green. So that would be that line right there, something like that.
Yeah, so it's the slope of that line that is the average velocity. That should be 60 miles per hour, right?
Mm-hmm.
And then the instantaneous ones are the slopes of those tangent lines, which again are more difficult to approximate.
Right. So that would be 70 miles per hour, and then 0 miles per hour is what I had here.
Exactly.
Cool.
Perfect.
All right. I'm going to stop the recording now.
Okay.